Welcome to pre-calculus.
All right, so we're going to do nonlinear inequalities. A lot of this is stuff that you've seen, and actually the first part is stuff that we've been doing in the last chapter. In the case of polynomial inequalities, we have a polynomial function, and it's either set less than 0, greater than 0, or less than or equal to, or greater than or equal to. And based on the inequality symbol, the solution is the portion of the graph which is either above or below the x-axis. So if this right here is f of x, and I want all of the x's for which f of x is less than 0, if I want all of the x's for which f of x is less than 0, then what I want is all of the x's for which the graph falls below the x-axis. So right here are the regions where the graph is below the x-axis. Okay? Now, what are the x values where that happens? Well, it's between x equals -2 and -4 here, and it's, starting at x equals 4 and going up. So those are the x values. So visually, that's what we're talking about, okay? When we look at the graph. When we analyze the graph, that's what we mean. Now, if we want the regions where f of x is greater than 0, then I want the x values for which the graph is above the x-axis. And the x values for which the graph is above are here. Okay, this is when the graph is above. And the x values are -∞ to here, and from -2 to +2. Okay? So we're looking for the x values where that happens. And when we talk about, including 0 and not including the 0, then, we're including the endpoint and not including the endpoint. Okay? All right, so let's start with...
Oh, you're doing this all in interval notation?
Yes, interval notation. So the steps are, we solve f of x. When we solve f of x, we extract the zeros, and we plot them on a number line to create a sign chart. Again, this is stuff that we already have been doing in the last chapter when we had to figure out domain. Remember? And then we're going to test values from each interval. So the first one here is x squared minus 8x plus 16 is less than or equal to 1. We're going to bring the 1 over to this side. We're going to factor this. This is going to be x minus 5, x minus 3 less than or equal to 0. Now, the x values that we can extract from this are 3 and 5. Okay? And we do we test values from each of the regions here. So for example, in the first region, x is less than or equal to 3. Pick a number. I like 0 because when I plug 0 in a number in an equation, I know what it's going to be positive 15 when I plot 0 in here. Positive 15, that means I get a positive number. A number between 3 and 5, if I pick 4.
3.1833.
Right, and all I want is the positive or negative, right? So in this parenthesis, I'm going to get a negative. Here I'm going to get a positive. That means it's negative. Here, if I pick a number greater than 5, I get a positive value. Now, what I want are the values that make this less than or equal to 0. Less than or equal to 0 means negative, and it also means that I want this region. So it's from 3 to 5, and because it's less than or equal to 0, then I do take the endpoint, so it's brackets. Okay? Now, let me talk about multiplicity for a minute. Okay? We know that if the multiplicity is an odd number, then the graph crosses the x-axis, right? What happens when the graph crosses the x-axis? The sign of the graph changes from positive to negative. Okay? However, when the multiplicity is an even number, all right, it bounces back. That means if before that number it was negative, then after it remains negative. What does that mean here? When I have the zeros on the number chart, okay, if the multiplicity is an odd number, then there's going to be a sign change. If the multiplicity is an even number, there's not going to be a sign change. So it'll be positive, positive, negative, negative. Do you see what I mean? All right. So that will help you when you're testing for the intervals. All right. Let's take a look at this one. So here I have x cubed minus 3x squared minus 22x plus 24 is greater than 0. Okay? I need to factor this, but it can't be factored. Nevertheless, I have to solve it. So I go to my rational roots theorem, P over Q. All right? P over Q for this one is plus or minus 1, 2.
Isn't there take out an x squared from x3 minus 3x squared?
It will still, you will not get a common term. This cannot be factored. Yeah, you won't get a common term. So 6, and what else?
8, 12, 24.
Well, let's try with 1. Let's see if 1 works. 1, negative 3, negative 22, and positive 24. 1 gives you 1, negative 2, negative 2, negative 24, negative 24, 0. It works. So this factors as x minus 1, x squared minus 2x minus 24 is greater than 0. All right? That can be factored. X minus 1, x minus 6, x plus 4, greater than 0. Now, I can put negative 4 here, and 1, and 6. Okay? So testing values below negative, okay, so for example, here is an easy interval. Between negative 4 and 1, I get 0, right? If I put 0 here, I get a positive value. Now, multiplicities here are all odd. That means the signs will alternate. So negative, positive, negative, positive. Okay, so the multiplicities of these are all odd. They're all 1, odd number. That means that here the sign will alternate. So if you put in one of them, then it's going to alternate. Negative, positive, negative, positive. Okay? The reason why is because at this 0, it's got to change sign. It's going to cross the x-axis. It's going to go from below to above or above to below. All right? Okay, so now I need the regions that are greater than 0. That's here and here. 0 itself is not included, so I'm going to have open parentheses, not brackets. So I have the region from negative 4 to 1, union 6 to infinity. It's greater than, not greater than or equal to, so the 0 is not included. All right? Okay, so the last, okay, so these are special cases. C, D, and E are all special cases. We're going to try to factor C, but it doesn't factor. So what we're going to do is quadratic formula, negative b plus or minus the square root of b squared minus 4 times a over 2a. All right, what I have here is x equals negative 2 plus or minus, this is negative 8 in the root, so it's 2i root 2 over 2, meaning x is negative 1 plus or minus I root 2. So what do I put on my number chart? This does not have a real solution, so there is nothing, no real solution. No, because that's for the number, that's for the real number system. So, so we need to determine determine whether the graph is above or below the x-axis. Well, what we're going to do, just figure out a number line for your, just put a number line, a random generic number line. And now let's just try to look at this. If you examine the function, right, notice that whenever, if you put any positive number into this equation, you're going to get a positive value, right? Because it's all being squared and added, so all positive values will give you a positive. What if you put a negative value in there? If you just examine it, if you put a negative value, you're going to square it, making it a positive. Okay, so this is the square of the number. This is just 2 times the number. The square is always going to win, right? So it's always going to be bigger. So it's going to win.
And in the one case that it's not, you have plus 3 anyway.
Right. So it's going to be positive here as well. That means multiplicity doesn't apply because you don't have a real zero. What this means is the function is positive everywhere. The function always resides above the x-axis. Okay? So what we want here, though, is negative, the negative region. That means it's no solution. Okay, so function is positive everywhere, so it's no solution. In this one, so here we wanted the numbers less than 0, which doesn't exist, right? So it's no solution. Here it's the same function, but we want everything greater than or equal to 0. And since the function is positive everywhere, it's always greater than 0. So the answer is negative to positive infinity. Okay? So function is positive all the time. All right, this next one is yet another exception, okay? When you factor this, you get x plus 6 squared. There is a multiplicity, so here is negative 6. So if I pick 0, let's say, I get positive, and because the multiplicity is even, it's going to be positive on this side as well. Well, the multiplicity is even. It could be 2, 4, 6, 8. As long as it's even at that 0, it's going to be the same sign on both sides. All right? Now, what I want here, now be careful. Less than or equal to 0, right? Is the function ever less than 0? No.
But it is at 0.
But it is possible for it to be 0, right? When is the function 0? At x equals negative 6. Okay, so function is never less than 0, but at x equals negative 6, it is 0.
Why is it negative 6? Oh,
Right? So the solution is just negative 6. Okay? Because we're looking for the numbers where it's either less than 0 or greater than 0. There is never a case where it's less than 0, but there is one case where it is equal to 0. So please, please, these exceptions are ones that you have to watch out for. Okay? So if this had just said less than 0, what would the answer be? No solution. If it said greater than 0, what would the solution be? Strictly greater than 0, what would it be? So if it said greater than 0, it would be negative infinity to negative 6. Negative 6 to infinity. So all reals except for negative 6.
Oh, if it was just.
If it was strictly greater than 0. Okay. Now, Next is rational inequalities. These are where, you have a rational function, but it's an inequality. So they contain a rational function. So whereas polynomial functions only change signs at its zeros, a rational function can also change signs at its point of discontinuity. Therefore, the sign chart must also include the zeros. This is a typo. It should say denominator, of the denominator. Okay? Because, look, here we have a 0, and yes, it changes signs. It goes from positive to negative. But look, at the discontinuity, it's negative on one side, positive on the other side. So do you see how it changed signs at the discontinuity? So we have to look at those as well. All right, let's take a look at this one. The zeros of this function are x equals negative 4 over 3. Okay, so we put that on the number line. However, I also have to include the 0 of the denominator. Okay, also 0 of denominator. And what's the 0 of the denominator? Negative 2. The rest is exactly the same, okay? But watch out, especially, okay, so let me tell, so at negative 2, okay, plug in a number less than negative 2, like negative 10, okay, and you will get a negative over a negative, so it's positive. Now, if you plug in a number here, like negative 1.5, what do you get? Negative. Now, this is a 0. So you can use your multiplicity. Okay? Does this have odd or even multiplicity? Odd, that means the sign will alternate, so that's a positive.
Doesn't the sign always alternate?
Only if it's got odd multiplicities. If it's got an even multiplicity, then no. It stays the same. So I want the answers that are greater than or equal to 0, the regions. So here and here. Now, rational functions. Can this function ever include, can this function ever be 0?
Yes.
Sorry. The denominator is never allowed to be 0, right? So here we have a restriction. X cannot equal negative 2. So when I'm giving my answer, I need to watch out for that. Therefore, it's negative infinity to negative 2 parentheses, okay, union negative 4 over 3 to infinity, and it can be negative 4 over 3. All right? Do you see the little intricacies there? It can be negative 4 over 3 because if it's negative 4 over 3, then the function is 0, which is fine. The numerator is 0 at negative 4 over 3, which is fine. It cannot be negative 2 because at negative 2, the denominator is 0, which it cannot be. Okay? So when we're doing this one, let's first write the restriction. X cannot be negative 2. X cannot be positive 2. Okay? All right, so what we're going to do here is solve this just like we did in the last section. You can factor the top if you want, but don't just yet because we're going to have to multiply it back. Right, we're going to factor, we're not going to, it turns out we don't need to factor. So I'm going to multiply everything by the common denominator of x minus 2. That means here I get x squared minus x minus 11 minus, when I distribute, 3x plus 6, x squared minus x squared minus 4x minus 5 less than or equal to 0. So x minus 5, x plus 1 is less than or equal to 0. On my number line then, I put -1, +5, but also what? 2. 2 because of the denominator.
Where the denominator is 0.
Right. All right. Here, I get a negative. And because x plus 1 has a multiplicity of 1, this is going to alternate. It's a good idea to check this part, okay? Well, yes, I'm looking at -1, so I go here. Multiplicity is 1. It's going to alternate. Now, this comes from the denominator, so check what happens here, okay? So if you plug 3 in there, it turns out you do get a negative. And here it's positive.
If we got a positive there, after 5 be a negative?
It should be a negative, yes. Okay, so what I want, okay, is the negative regions here and here, but remember it cannot equal 2. So it's -infinity to -1 with a bracket and 2 parentheses 5 bracket. Okay, this homework will be due Monday?
No, we have Monday. Yeah, we do. Last period.
Monday, then.
Can we start working on it?
Oh,
No. It's Friday.